Welcome to part 10 of electromagnetic induction. In this video, I shall explain the solution of question 6.10 given on page 230 of NCERT Physics part 1. This is from the chapter 6, electromagnetic induction. In this question, a jet plane is traveling towards west at a speed of 1800 kilometers per hour. What is the voltage difference developed between the ends of the wing having a span of 25 meters if the Earth's magnetic field at the location has a magnitude of 5 into 10 to the power minus 4 Tesla and the dip angle is 30 degrees? So the question says that a jet plane is traveling towards west. This is my west. So it's traveling towards west with a speed of 1800 kilometers per hour. So 1800 kilometers per hour is equal to 500 meter per second. We need to convert all the units to SI unit. And the span of the wing, this shows the span of the wing as 25 meters. And the magnetic field at the location is given as 5 into 10 to the power minus 4 Tesla and the angle of dip is 30 degrees. So the vertical component of the magnetic field will be equal to B sine 30. So this is the plane which I have drawn. This is the span of the wings, 25 meters. As the plane proceeds towards the west, we can consider an imaginary loop in the horizontal plane. So as the plane proceeds, the breadth of the loop remains the same, but the length of the loop keeps decreasing as the plane proceeds towards the west, and the plane of the area of the loop is lies in the horizontal plane. So the area vector of the plane which is perpendicular to the horizontal plane of the imaginary loop is parallel to the vertical component of the magnetic field. Here, if you see, the area vector is perpendicular to the horizontal component of the magnetic field. Now, since flux is equal to B dot A, that is equal to BA cos theta, theta being the angle between the magnetic field and the area vector. So as we have seen, we form an imaginary loop with the span of the wings forming one end of the loop, and this is the length of the loop which keeps decreasing as the plane moves towards the west at the rate of 500 meters in 1 second. And theta is being the angle between B and A. We see that the area vector of this plane which lies in the horizontal plane is perpendicular to the horizontal. That means it's in the vertically down direction. So this area vector, the area vector would be parallel to the vertical component of the magnetic field, and area vector will be perpendicular to the horizontal component of the magnetic field. In this case, theta becomes equal to 90 degree and cos theta becomes equal to 0. So we realize that the flux through the loop is due to the vertical component of the magnetic field, that is BVA, as theta is equal to 0 for the vertical component of the magnetic field, and cos theta becomes equal to 1. So d phi dt, that is the change of flux, now could be either due to dBV dt or due to dA dt. Since the magnetic field of the Earth is uniform, dBV dt will be equal to 0. That means BV is constant. BV is constant. So the change of flux is due to the change in area of the loop. So as the plane keeps proceeding towards the west with the wings on one side forming one side of the loop, that is 25 meters, the length of the loop keeps decreasing at the rate of 500 meters in 1 second. So the area enclosing the flux keeps decreasing every second, or it decreases at the rate which is equal to the velocity of the plane, because phi is equal to BVA, that is the vertical component of the magnetic field of the Earth, into A, which is equal to, so d phi dt becomes equal to BV dA dt. BV is also equal to B sine 30. This is B and this is 30 degrees. So this is the horizontal component and this is the vertical component. So BV can also be written as B sine 30 into dA dt. Again, in the area of the loop being length into breadth, the breadth remains constant. So B sine 30 into B into dl dt, which is nothing but the velocity, B sine 30 into 25 meters into dl dt is the velocity with which the plane is traveling, that is 500 meters. We put the value of B as 5 into 10 to the power minus 4 and sine 30 as half into 25 into 500. We get the value of induced EMF, which is equal to, E is equal to 25 into 10 to the 2.5 into 10 to the power minus 4 into 25 into 500 volts comes to 3.125 volts as the induced EMF. In case of any doubts or clarifications, you can log on to www.olympiadtester.com/mentor. Thank you.